We're going to get a talk from Zakir, who's an assistant professor at Stanford and also the co-founder and CTO of Censys, to give us a talk on that system. So go ahead.
Awesome. Thank you, Alex. Good morning, everyone. It's good to see folks. I wanted to take a moment and talk about what's been happening at Censys really over the last 10 years since we left the University of Michigan. For folks who don't know Censys, I actually want to start at the beginning. Censys really started with ZMAP originally in 2013. ZMAP was a scanner that let us go out and conduct these very large port scans of the entire V4 address space. And after we released ZMAP, we said, okay, there's a lot of really sort of interesting data here, and I think we saw a lot of promise in that data, but it was still pretty hard to use ZMAP in practice. It was hard to find networks that would let you do scanning. It was hard to find networks that maybe had the sort of the right configuration where you knew you were getting right data. And as a result, we decided to take all the scans and we'd sort of tarball them all up, and we post them online, and we created this site called scans.io, and it was really us and HD Moore at Rapid7 at the time who were posting these large tarballs. And people said, okay, this is great, but you're telling us we need to download terabytes of data every time we want to answer any question about the internet, and this is sort of obnoxious. Can you essentially answer our questions for us? And we became this sort of email-based query service where people would email their questions, we'd write a small Python script, we'd run it, and then 3 days later we'd send back the answer to them of whatever their question was. And this sort of continued to evolve, and we built Censys, which originally was really supposed to be just a query engine for academic researchers to ask questions about internet scan data. People could go in and say, what percentage of websites are supporting SSL v3 versus TLS 1.0? How many services run Modbus, the control system protocol on the internet? But after we launched Censys, it gained a fair amount of traction within industry. It was never really designed for industry. It was designed for academic researchers, but it gained traction, and a lot of folks said, we can actually look up things on Censys a lot faster than we can find them by running our own scans on our networks. This is actually pretty efficient for us. And so around the 2018 timeframe, there were about 50,000 users on the Censys platform, and this kind of made us say, okay, what are we going to do with this? What is the future of Censys? And we made the decision at that time to spin out the project from the University of Michigan into a standalone company and to provide this data commercially to governments and to enterprises, and then to continue to provide that data to academic researchers. And since then, there's been a lot of evolution. We've actually re-architected pretty much every single aspect of how Censys operates in the last 10 years from when we told everyone how Censys worked and what happens today. And this affects everything from how we scanned. Originally, we just sort of ran scheduled ZMAP scans and a cron task and then aggregated them all together and then shipped them, to how we think about who should have access to data, how we should model the systems on the internet, what can be done with the data, what data actually needs to be collected through internet scanning. And if I look at sort of the highest level across all of this, what I would say is there's been a pretty big evolution in actually our design goals. In 2015, the design goal was make internet scan data available to everyone. In 2025, the goal is to build out a map of what all of the actual infrastructure is on the internet. Now, these might sound similar, and we still use internet scanning quite a bit, but these are fairly different goals and affect sort of how we design Censys a fair amount. The first is that, for the most part, most people in industry don't want internet scan data. Scanning is a how, not a what. We started with the how. We had started having built ZMAP, but really a big question is, how do we find everything? How do we figure out what everything is? How do we figure out who owns everything? And sort of driving all that context is really just as big of a challenge and just as important as the identifying everything on the internet. But the vast majority of people, right, don't want to be thinking about banners or cert hashes. They want to be thinking about this specific version of a Cisco router that has this specific problem on it. Second, big is this question of what does coverage look like? The reality is that for most academic questions, you actually don't need perfect coverage. When we put out ZMAP originally, we estimated we saw sort of 97% of the internet. We said, this is good enough to see all the internet, or to answer these questions. But for an operator, missing 3% of what you have on the internet is a massive problem. If you're tracking a threat actor, missing sort of parts of the internet that are harder to reach is a massive problem. I mean, actually, the services that are most important to people actually many times have no real impact on the high-level statistics of how much of the internet you see, because the most important things on the internet from a security point of view are the things that should never be on the internet in the first point. They might be things that only a couple dozen or a couple hundreds of these instances exist, but when they do exist, are really bad. Another is the importance of accuracy. Now, I think we all think that data accuracy is important, and we hold it to the highest esteem. Accuracy to us is actually more important than coverage, which I think is surprising to a lot of folks we talk to. And because of this, we actually prioritize making sure everything in the data set is correct more than seeing everything on the internet, which means we constantly underestimate the size of the internet. But the reality is bad data uses up a massive amount of time for operators, right? And they'd rather fix real problems, even if they don't know about all the real problems, than burn a bunch of time trying to chase something down that isn't real. So it's actually more important to tell people and be 100% confident in what you tell them is right than it is to find everything. And then last I want to bring up is the notion that Censys has to operate in real time. A lot of the systems we like to build run once. Actually, most of the academic work on scanning is all set to build to run once, to find everything once. Nothing about the real world, though, really operates once. Research questions oftentimes operate once, but for an operator, they need to be able to ask about this question at any point in time. They need to be able to go back in time for an incident. They need this real-time visibility, and how you develop something to be a real-time system looks actually quite different than how you build something that runs once. The second thing is we originally thought that we wanted to provide all this data to everybody. And the reality is providing all data to everybody doesn't actually necessarily increase the security of the internet. There's a question of what data needs to be provided to the right people so that we're actually improving internet security, and how do you mediate access to all of that data. The other thing that happened since that time is we learned a lot more about internet services. And a lot of this is work done by Liz Zajkovic, who is in the audience today. And she had this big finding a few years ago that said, really, most services don't live where you think they will live, and the most interesting security services definitely don't live where you think they do. Most things don't live on their standard port. So this whole idea of you're going to run one scan on port 80 and find everything really isn't true. You'll find some things, but you'll find a biased set of things, and you'll find only a subset of things. The most interesting things live in this long tail of other ports that you're not going to find by brute forcing. The second is the internet became more ephemeral, and we started to care more about the ephemeral assets on the internet. Because of cloud services and a lot of these auto-scaling containers, the lifespan of services within clouds like AWS are very short. We also started to care much more about things like home networks, because home routers became compromised en masse and were being used to launch attacks, and those became much more important to the internet security. We found that scanning from one place does not have the full visibility we expect. And actually, this is getting worse as countries are starting to balkanize and prevent access to other countries for what their internet looks like. And much of the internet is not accessible over IPv4 anymore. A significant fraction, an increasing fraction, is only accessible by name, is only accessible over IPv6. And I think, interestingly, folks, we're much more worried about named assets than we are about IPv6 assets. Lots of things that are on IPv6 are dual-homed, and sometimes things peek through on v6 and not on v4. But if you compare that problem to things that have names and URLs on the internet, that is a much, much larger problem for folks, and those things can be found. They can be found through things like passive DNS. They can be found by attackers much more easily than many of those v6 assets look like. Today, Censys does not use ZMAP. We run a set of continuous scans that operate sort of over time, and this has been a big change. We don't run anything on a scheduled basis. We run everything continuously, and there's a mix of scans that say what are the sort of most important ports of people because they're either security relevant or people expect them. We do more frequent scanning of networks that we think are going to change more often. And then we do a background scan of all 65,000 ports. And we don't expect to find everything on 65,000 ports at this rate, but it gives us data to then train models against to figure out to predict where some of these services are going to be in the future. And then the last thing I'll bring up here, and this is actually quite important to us, is we're refreshing all of the data daily now, which means that we're actually pruning things out faster than we add things. And we're not necessarily scanning uniformly anymore. So if you look at the data in Censys, we're maximizing for finding the most things, but that does introduce bias compared to a completely random walk of the internet because we're scanning things like cloud networks more often. We're scanning certain ports more often, and there are differences between the security postures of those ports. There are differences between the security postures of those networks. We run all these scans from a set of globally distributed vantage points. We essentially co-load equipment at large internet exchange points. We peer with different tier 1 networks at those vantage points, essentially to reduce the number of router hops where packets might be dropped along the way. We tier with essentially the set of tier 1 ISPs in a region that we think are going to provide the best visibility in that region. We run all of this continuously. At this point, we check around 200 different protocols. All of this data then gets streamed into Google Cloud, where we maintain this. And I'm not going to get into a ton of detail here, other than to say, when you bring this all together, this is about 1 to 2 million reads per second and about 500,000 to 1 million writes per second of data that is updating between the scans, the updates, the host, the website certificates, all of these pieces. This data is actually getting written at a rate much faster than we ever originally expected. And actually a huge part of the challenge of running this is not actually the scanning and setting up packets, it's how do you actually capture and keep track of all of that data? How do you do that historically? After compression and delta encoding of all this data, we're adding about 500 terabytes of data per year that we are scanning, and that adds up over time. So how are you letting people make sense of that is actually a massive challenge that is much worse than anything I expected going into this project originally. I thought much of our data would be just, how do we find this? This is actually a much bigger issue. When we think about what does Censys see, we really think about this in terms of coverage and accuracy. How much of the internet we're finding, and of the data we are returning, how much of this matches the current live state of the internet at the time someone tries to pull that data out of Censys. Now, there isn't a perfect ground truth to compare against, because if we had a better ground truth to scan with, then we would scan using that better approach for ground truth. So what we do is we look at subsampled scans of all 65,000 ports, which we can then use to say, of these subsampled scans, how much of those do we see in Censys? We can take the data that's in Censys, and we can check the accuracy of that data against what the real internet looks like at that time. And then we can also look at a number of other scan engines which have emerged over the past couple of years and say, what are the differences between what these engines see? If we look at what Censys sees compared to the random sample, which is, I think, the sort of the cleanest a data sample that represents the internet, we see very good coverage of the top 10 ports and the top 100 ports, and then this drops over as you go down sort of the long tail. And this is expected, right? We scan comprehensively the top 10, top 100 ports. The rest of this becomes more predictive, and a lot of stuff on the 65,000 ports actually can't be predicted. If you just put something out there on a random port, like, we're not going to predict that's going to happen. What we're going to see are things like backdoors and web shells and debug consoles and things like this, but we won't see the random other things out there. They simply can't be predicted if a random person does a random thing. If we compare this to the other scan engines, we see sort of similar numbers for Censys. These numbers go down, which is a little bit unintuitive, but it comes down to whether or not you are capturing a bunch of honeypots in this data or not. And there are a lot of hosts out there on the internet that actually speak the same protocol in all 65,000 ports. And so if you look at hosts, the number of hosts that have this behavior is very small. The number of services that belong to those ports is actually the majority. To those hosts is the majority, because you have a couple million hosts that all speak on 65,000 ports, and it really skews that data very heavily. But what might surprise folks here is that the coverage from other engines actually looks lower here compared to Censys. Now, why this might be surprising is if you go and you do a search in any of these engines, you'll see dramatically more data in all of these other engines compared to Censys. And so these numbers look quite different of how much of the internet is actually out there. But if you take this data and then do a follow-up scan in real time to figure out which of those services are actually live at the time they're querying out, it is a very small fraction in some of these cases of how much of that data actually represents what the internet looks like. So if you take the data that is in all these engines, check it in real time, and then only keep the things that are still there, you actually see a completely different set of numbers. And what it comes down to is the accuracy of the data is dramatically different between some of these engines. But if you just aggregate data over all time, your coverage looks really solid in terms of raw numbers, but then it could be that 9 out of the 10 data points you get back out of that service are actually wrong. A lot of this actually comes down to, at the end, the freshness of the data, and this varies dramatically across engines. One of the things that we've always been very careful about is pruning out the stale data very quickly out of Censys. All of the data is essentially under 2 days old, because probabilistic. You could be scanned at a different time within a 24-hour period. But every piece of data will therefore be less than 2 days old. Just depends on where you fall in that distribution. If you look at other engines, some of these will take data actually like up to 5 years old and kind of mush this together and say this is the current state of the internet. And what you get is a totally different looking internet when you look at that, because you see double counting in a lot of these regions that are quite different. In terms of the I'll try not to breathe too hard. Okay, we continue to provide access to researchers. And over the last, I guess, 7 years since we brought up 7, there's been about 500 research papers that have used census data, which has been super cool. It's been really exciting to see how that data has been used. We had to change how we provided access to data. And I will say this has ended up being way harder than we ever imagined to figure out how to provision access for researchers. It's really easy to provide access to folks who have these sort of long-running reputations, who have Google Scholars. But the number of people who have that large reputation is a very small percentage of the total number of researchers who want to start their research careers or want to do class projects and things like this. And this is actually very, very hard. I have a lot of respect for the other companies that provide this access to this data, because it's really thankless. And for the reality is we don't have a good way of doing this today. It becomes a very hard value judgment of, is a poorly worded request in English legitimate or not? Is this someone who's starting a research career and doesn't have a good idea what they want to do, or is it malicious? And we have seen actually university accounts compromised to access census data by attackers. We have seen research access requests used later on in criminal cases. There is sort of a market that has emerged for access into this data that is hard to distinguish between junior researcher and malicious requests of this data being used to actually mount attacks. And the data about where to find the hard things on the internet has actually become quite valuable. The #1 attack vector today for ransomware, for a lot of the critical infrastructure attacks, are these internet-facing devices, which means we don't have as that visibility into that is becoming more important. I'm going to quickly go through these. I know I'm late on time. Just want to call out quickly what is sort of the business that supports this. Censys at this point is self-sustaining, which means that we're able to sell this data to enterprises and to companies, and then provide that data back to the community for free, and it works out. People are using this for a variety of different purposes, which range for some companies just trying to understand what do they have on the internet, which is becoming exceedingly hard. For a lot of large enterprises, these companies will have things in tens of thousands of cloud accounts. In a lot of cases, they can have upwards of 50 different cloud providers, and simply keeping track of what that is at any given time and responding quickly, it has become a nightmare. Big usage is actually by big CTI companies. So if you name any big security company, our data is probably flowing into them, and they're using this to actually track adversary infrastructure. They're using it to fingerprint that infrastructure. They're using it to look for connections and what's going on. Governments are using it to protect critical infrastructure that leaks out onto the internet. If you look at every single sort of critical infrastructure provider one by one, the number that have things that leak out on the internet is small. But when you do look at the aggregate, you will actually find hundreds and thousands of different water distribution control panels and these types of interfaces that are out there because people make mistakes sort of in this long tail of utilities. And last is really on the supply chain and insurance side of things, people trying to make sense of both their suppliers and their customers using this data, trying to understand their security practices, trying to understand the vulnerabilities of their supply chain and how they affect them in their own security. So with that, I'm happy to take any questions in the last moment, and I'll be around for the next couple days. I do want to mention we are hiring. We were started by a bunch of researchers. There's actually a ton of really, really hard, interesting sort of questions at the intersection of research and engineering here, of how do you actually make this work. If this sort of work is interesting, I would love to chat with you this week. Thank you.
So lots of fun stuff. We're running a little tight on time, but I think we have time for one question. Can we get the mic all the way down to the front? It's going to take the entire time just to get Sergey the mic. All the way down, all the way down, all the way down. You can meet the mic. Excellent.
Yeah. Thank you. Very interesting talk. You mentioned 3% are not visible, and the most interesting. So any ideas how to look at this 3%?
Yeah, I mean, this is sort of the crux of the hard issue is how do you do this? Part of it can be found programmatically. Part of it is a lot of the fingerprinting and the context and making sense of like what those things are and how they've ended up there. A lot of it's understanding the why. What are the devices? Who deployed them? Is this a network-based pattern? Is this a manufacturer-based pattern? Is this a pattern due to compromise of those devices? But a lot of the question comes down to, can you figure out what the pattern is? And then if you can figure out what the pattern is, you can predict where others will be. Some of them, you just won't find at all. It's something you'll only find through brute force. On the name side, you might only find through passive DNS. But a lot of it is how much of it is predictable and how do you build better prediction for where those things will be and when they might appear.
All right, thanks to you again.